Periodic Table of Elements by Minji Kim. When I say table, do you think of your desk, or maybe the dining table, or perhaps even one of those fancy desks that go up and down? Well, we're here to talk about a completely different table, which is completely unrelated. This is the periodic table of elements. You've probably seen this multiple times in your life, and might even associate this table with chemistry. You also probably know a couple of the elements listed on this table, like hydrogen, helium, carbon, nitrogen, oxygen, sodium, titanium, copper, silver, and gold. While you might know these, you also probably don't know a couple of the other ones, like cadmium or livermorium. Which brings us to the question, what exactly is an element? An element is a substance made of only one kind of atom. There are 118 known atoms, with only 94 of them occurring naturally. Take this gold, for example. It occurs naturally, and assuming that this is 100% gold and pure gold, then when we zoom in to an atomic level, we can see that the only atoms here are gold atoms. If we were to use a silver chunk that was pure silver, then we would only have silver atoms. Let's talk about symbols. This is a symbol. More particularly, it's the symbol of hydrogen. All elements have a symbol. Each symbol is 1 to 3 letters. The first letter is always capital. The second letter is lowercase. Next, let's talk about the atomic number. Atomic number is the number or order in which the element is listed in. So hydrogen is 1, helium is 2, and so on and so forth. This is the general atomic weight, the weight in which the atom is most stable. In this case, for hydrogen, it's 1.008. This is the name of the element, hydrogen, in this case. It could be helium, strontium, ytterbium, francium, or so many others. But in this particular case, it's hydrogen. Let's talk about the groups and periods. The groups are the ones that vertically line up. So group number 1 is hydrogen, lithium, sodium, and so on and so forth. There are 18 groups. Elements have the same number of electrons in their outermost shell as their group number. So hydrogen, lithium, and sodium all have 1 electron in their outermost shell, along with others. And if element in row 2, if you choose an element in row 2, they will have 2 electrons in their outermost shell, and so on and so forth. Periods are the horizontally organized rows. There are 7 periods. Now that we know about groups and periods, let's talk about patterns. First, let's talk about the atomic radius. As you go from the left to the right, the atomic radius decreases. And as you go from top to bottom, the atomic radius increases. Like this. Next, let's talk about ionization energy. Ionization energy is the amount of energy required to remove an electron from the atom. The smaller the atom, the harder to remove an electron. So helium would be one of the hardest atoms to remove an electron from because it's one of the smallest. As you go from left to right, the ionization energy required increases, and as you go top to bottom, the ionization energy required decreases. Let's talk about electronegativity now. Electronegativity is the measure of an atom's attraction to an electron, or how much an atom wants an electron. An atom most stable with 0 or 8 electrons. So, in this case, if we were to choose fluorine and lithium, complete opposites of each other in electronegativity, we would find that lithium has one electron and would much rather get rid of it and become helium. And then there's fluorine, which really, really wants another electron to fulfill the rule of 8, in which it would be most stable and become neon. So, as you go more to the right, the electronegativity increases and electronegativity decreases when going from top to bottom. Next, we'll talk about the different types or of elements. There's the alkali metals, the alkaline earth metals, the lanthosides, the actinosides, the transition metals, unknown properties unknown properties elements, post-transition metals, metalloids, reactive nonmetals, and noble gases. Alkali metals are the most reactive, and noble gases are the least reactive. Let's talk about history. Dmitry Mendeleev, a Russian chemist, was the original creator of the periodic table of elements. Even with only 60 elements, he managed to start a base for the table. He eventually concluded that his table wasn't wrong, but was rather incomplete, so he predicted a bunch of the elements that would be discovered in the future. It was first published in a textbook around the time when many others started publishing their findings. But the thing that pointed Dmitry Mendeleev out was Dmitry Mendeleev became obsessed with the periodic table. At one point, a French scientist discovered a new element. Mendeleev's predictions and the data that the French scientist collected didn't match up, and Mendeleev was so confident of his predictions that he published a paper on why the French scientist was wrong. Even crazier, Mendeleev was right. The data collected by the French scientist was inaccurate. Obviously, over time, new elements were found, and the elements were no longer limited to 60. This is our modern day periodic table of elements. It has 118 elements, 94 of which occur naturally, while the others have to be artificially created in labs. This is the periodic table of elements.